In this problem, we're asked to determine the stations on the relative gradient profile for the curve shown here. We're going to zoom in a little bit here, and we can see the PC labeled here, and here's the cross slope that we're going to need to use to understand this curve and help us develop the relative gradient profile. And in particular, this dimension of 17 feet but for 1% change in cross slope is going to be very helpful for us. And now moving on to the other side of the curve, the PT. We've got our components for the end of the curve here. And again, we see that 17-foot increment for a 1% change in our cross slope. So here's our template for our relative gradient profile. This is for a simple curve. You'd have a slightly different setup here if we were using a spiral curve or something else. So we can start putting our values in. We were given from our design plans the PC station, the point of curvature 18 plus 49.37. Then our PT was also a given, station 23 plus 90.39. There's a design super elevation of 4%. We could see that from the design plans as well. And this value of 17 feet is going to be really helpful for us to go from point B to point D. So that's adverse crown removed at point D to our design super elevation. Because it's 4% is 4 increments of that 1% change in cross slope. So 17 feet times 4 is 68 feet. It's the same thing on each side of the curve. We have a symmetric curve here. We've got the same increments and super elevation. So that's again 68 feet for that super elevation runoff, the distance from design super elevation to adverse crown removed. Next, with that value, for North Carolina Department of Transportation plans, the standard is to use 2/3, 1/3 runoff. That's what we're showing here on this relative profile gradient as well. So 68 times 2/3 is 44.33 feet. That's going to help us establish that value of adverse crown removed. And then from that, we'll find the other values of our points on our relative gradient profile. A through H is what we're trying to define here. So now we're just subtracting that 45.33 feet from our PC station. We're going to get a value of 18 plus 04.04. Each of these increments shown here, B to A, B to C, F to G, G to H, are 2 increments of cross slope going from normal crown to adverse crown removed to reverse crown. So each of these increments will be 34 feet, 17 feet times 2 increments of our cross slope. So we're going to subtract off 34 feet from our adverse crown removed at B to get the station at A, which is 17 plus 70.04, again 34 feet earlier than station B. Point C is 34 feet past point B, so that's 18 plus 38.04, and then another 34 feet to point D, which is 18 plus 72.04. This obviously isn't drawn to scale, but this is the kind of standard template for our relative gradient profile. Now moving to the other side of the curve on the PT side, we can find our adverse crown removed station on that side, which is point G. We're going to add 45.33 feet to our PT station of 23 plus 90.39. Then we're going to go 34 feet over to get our point H, 24 plus 69.72. We're going to go earlier 34 feet to get from G to F. That'll give us a station of 24 plus 01.72. And finally, our station of our last point of the design super elevation, point E, is 23 plus 67.72, which is again 34 feet earlier than point F. Obviously, you don't have to do them in this pattern. This is just the pattern that I followed. You could do it many different ways to actually get all of these values. But ultimately, what we're trying to do here is solve for the stations of A through H in our relative gradient profile.